Good morning, everybody. How are you all doing? Hope you are doing great today. Bright and sunny outside. Warm, also very warm outside. I hope you are doing great today, wherever you are watching from. And good day to you. And if you have been watching my presentations on this area, you'll be noting that so far I have talked about how to collect information as a sample from a population, how to represent the data by charts. Okay. And now we are ready to talk about center of the data. So I've collected information from a sample, which is a simple random sample from a population of interest. I've collected that information. Of course, I cannot reach the entire population. Suppose the college has hired me to find the population mean age of all students in the campus. Can I reach all the students at any one point of time? You all know the answer. It's not practically possible. Where is the time? Where is the money to do all that? So I have to work with a simple random sample from the population. So I ask each and every student in my sample. My sample can be of size, say, 50. I ask each of the 50 students, what was your age at your last birthday? I add the 50 numbers, divide by the 50 because that's my sample size, and get a sample mean. Okay, so sample mean. What is the sample mean all about? Why do you want to know about the mean? You may have asked these questions before and you have not found easy answers to it. Why all statisticians are interested in finding the mean of the data? So today I'll try my best to answer that question for you. And please hang around till the end of this presentation. It's not a long presentation at all. And if you like my video, please give me a thumbs up. And please do not forget to click on subscribe button, and also please do not forget to click on the notify button, which will notify you every time I upload a new video. So here I go. Describing the center of a data set. So we have lots of numbers. The numbers do not make sense by itself. I want to find out where most of the data are located. Okay, so that is the reason behind working on center of a data set. Okay, but there is more to it than just the sample mean that I talked about. So let's proceed. Overview of mean in numerical data sets such as ages of students. The mean of that data set is the familiar arithmetic average. What is arithmetic average? You all know. You add the numbers, divide by the sample size, you get the mean. That is the average. Calculation is sum of the observations divided by number of observations. Notation for variables and observations: x is the value observed, such as a person's age. N is your sample size. And uh, these are x1, x2, x3 up to xn are the values of the variables, and the individual values in the data set. Okay, so we sum all the ages in my example. That sum is indicated by that particular symbol. Why is it there? Have you ever questioned yourself, why is that symbol there? Because it is Greek capital S, means sigma. Okay, in Greek they call S as sigma. So it's Greek capital sigma, which in algebra indicates, or in statistics also indicates, sigma, sum. Okay, so the sample mean is given by x, small x with a line in the top. Some people still call it x. It's not x. It is x with a line in the top called x bar. X with the horizontal line on top of it is x bar, as if it is a bar or a line on top of x. Sum of all the x's divided by the sample size. Okay, that's what is in the definition. Okay. The example in the chapter introduction described a study that investigated how thinking about exercise mix might affect food intake. Data on calories in snacks taken by people in each of the three groups: control, read about, fanta, walk, and read about strenuous exercises are given in table 4.1. Okay. So, dot plots of these data were given in the chapter introduction and reproduced here as in figure 4.2. So, you have three horizontal lines. These are the numbers. Okay. Calories in, these are what measurements of calories in snacks people consuming. Okay. Three groups. Calories in control group, they're not reading much. In the fun group, okay, they're reading about fun walk. And in the exercise group, they're reading about strenuous exercise after reading. So control group, they're not doing anything. Control calories fun group, they're reading about fun activities, fun walk, and strenuous exercise. After finishing reading, they will do strenuous exercise. So what's happening here? Look at the spread in the distribution. Spread is from the lowest dot to the highest dot. People who are not going to do anything after reading, they're the control group. Okay. So notice the spread, the lowest to the highest, is much smaller in the top group, which is the control group. Okay. People who are reading about fun walk, what are the calories? What are the snacks they are going to consume? Their calories is little bit higher than the control group. Remember, control group after reading going to do nothing, whereas in the fun group they're reading about fun walk, which they will do after reading. So they're thinking they're consuming snacks which are a little bit higher in calories than the control group. And then look at the lowest horizontal line, which is for the group which is reading about the fact that they're going to do strenuous, hard exercises after finishing reading. So they are consuming foods which are much higher in calories because they know they're going to do strenuous exercise after reading and then they're going to consume snacks. So, what is the bottom line? The bottom line, the spread from the lowest to the highest and the center of the data are different in each case. For example, the central center of the calories control group, which are not going to do anything after reading, the center is the number on the horizontal line, top horizontal line with the highest number of dots. Look at the center. However, look at the spread also. The spread is from the highest dot minus the lowest dot. Okay. So the center of the control group is on the towards the left because they're going to consume snacks which are not too high in calories because they're not going to do any exercise after finishing reading. Okay. Bottom line, this is a dot plot. The dot plot shows the from the lowest to the highest. Each dot on the number line represent how many times a number occurs. So for example, in the control group, the dot with the number on the horizontal line, top horizontal line, with 1, 2, 3, 4 dots is the number that occurs most frequently here, four times. And that is where the center is. For the fun group, there is somewhere in the middle. So there's numbers which occur 2 times, more than one number, and that's where the center is. And in the exercise group, of course, they've shifted to the right because they're going to consume snacks after doing exercise, strenuous exercise, which are high in calories. But you locate the point with the highest number of dots on the bottom axis, on the bottom line, and you will see it's around, what would I say, 780 calories. Okay. So this is your data. You have the control group, plain group, and exercise group. Okay. As it is, we have observed from the dot plot, the control group is the one which is on the left, lowest mean, lowest center of the data, and lowest spread in the data. highest mean or average of the center is for the exercise group. The fun group, the center is shifted towards the right from the control group because they're going to do some fun work after reading. So they're thinking of consuming snacks which are slightly bit higher in calories than the control group, which are not going to do anything. And for the exercise group, they're the highest center. Why? Because they're going to do strenuous exercise after finishing reading. Okay, so the for the control group, the sum of the sample data is this, and then divide by the number of entries or number sample size is 15. It's 335.2. For the fun group, this is 617.5, and for the strenuous exercise group, it is 740. And as I said, the center of the lowest horizontal line, which is the group which is going to do strenuous exercise after finishing reading, the center is the highest on the right, 743.7. So you may be asking yourself, how do I calculate the center of this data? Of course, I can write the numbers, add them up, and divide by the sample size of 15. Is that a clever way to do it? No. We are going to use TI-84. So friends, please, if possible, get a TI-84 calculator. We will work with the control group for now. What are we going to do? We are going to enter the data from the control group. Okay, the calories of the snacks they're going to consume after doing reading, and they're not doing any exercise. We are going to enter the individual data points in list 1 of this calculator. So how do I do that? First, I clear the memories of the calculator. So I do second button, then the plus button, then the 4. Second, plus button on the bottom right, second is on the top left, plus on the bottom right, then number 4. We get clear all list on the calculator screen, hit enter, done. Then stat and 1 button. Okay, and you see L1, L2, L stands for list. So I'm going to enter the control group data in L1, which is 340, 300, then 329, then 381, then 331, then 445, then 320, then 256, then 252, then 342. Remember, all these numbers are going in L1, list 1 of the calculator. So the last number I entered is 342. After that is 332, then 296, then 357, then 505, and then 242. And I have 15 data points. So after I enter the last data point in L1, which is 242, and hit enter, the cursor, the black rectangle, goes to line 16 and waiting for us to enter data in 16, which we are not going to do. Why? Because I do have only 15 data points. Now I'm ready to calculate the center of this data set in L1. How do I do it in TI-84? We press the stat button, then highlight calc in the top row, then number 1, which is one word stats. The first line is list is L1, always set. We don't have to do nothing. We go down to calculate and hit enter. The first number is the mean, X bar. Sample mean is 335.2, which you have in your calculator. And you can repeat it for the 2 other groups. Okay. So decimal precision, how many points should we go? We should at least go 1 point, 1 decimal point more than what we have the original numbers. Using more digits of decimal accuracy for the sample mean allows the value of the mean to fall between possible observable values. Rounding practice, common to round sample means to one or more. Remember our data set was, look at the data set, no decimal points. So we round it to one more decimal points. So the sample mean is 335.2. Okay, and we can do similarly for the other two groups. As we discussed before, the people who are thinking of doing strenuous exercise after reading, they are going to consume on the average more calories from snacks. Okay, so we go one more decimal point than the original data for accuracy. So far we have been dealing with sample, it's X bar. Key point to remember at this point, when we deal with population mean, it is the same formula. But instead of using X bar as a population mean, we use small m in Greek language, which is written as what is shown on the screen. It is called mu. It's small m indicates population mean. M, population mean. Okay. So the question is, we have found out the center by calculating the sample mean or the population mean. What exactly does it mean? Have you ever thought about? So think of a balance. Okay, you put weights on the different parts on the balance. Balance is a number line basically. Put weights corresponding to individual data points in your sample. So weights on the balance at individual data points. The mean, the arithmetic mean or the sample mean is where the balance is balanced. That is, if you put a fulcrum or an edge at the point where the arithmetic mean or the sample mean is located, the fulcrum or the balance will be balanced at the fulcrum point, which is the mean. Okay, neither it will go up nor it will go down. Remember, we are putting weights at the points, individual data points, we are putting weights, and the fulcrum, if we put a fulcrum under the at the mean position, the balance will be balanced. The right arm will not go down, the left arm will not go up. Everything is balanced. So it is the balancing point of a fulcrum of weights. That is what the mean is all about. But then the question is this the only measure of the center of the data? No, no. There are other measures of the center. And one of the measures of the center of the data set that is commonly used is the median. Okay. So median is the actual center, geographic center of the data set. That is, 50% of the numbers are below the median on a number line, and 50% are above the median on a number line. The data set is geographically balanced at the median. How do you do it in the calculator? Within a, but if you're doing in a piece of paper, you arrange the numbers from the lowest to the highest. For odd sample sizes, the median is the singular middle value. And for even sample sizes, the median is the arithmetic average of the two center numbers. Remember, the numbers are to be arranged initially from the lowest to the highest. Okay? And if the sample size is even, such as 8, 10, then you take the arithmetic average of the two numbers in the middle. On the other hand, if the sample size is odd, such as 15, then the numbers, when arranged from lowest to highest, the number in the center is the median, 7 numbers below it, 7 numbers above it. So how do we calculate the median? Remember, we have already entered the data from the control group in L1. Okay, so we just have to hit stat calc 1, okay, L1, and hit enter. And the median, you don't see the median in the first screen, so you scroll down with the down arrow key to the second screen, and you will see the median is 332. Median is 332 in this case. What does it mean? That means 50% of the numbers, so 7 numbers below 332, seven numbers above it. We know in number of numbers, sample size is 15. Hence, the number in the center is the median. Okay. Notice in this case, the sample mean was 355.2 and the sample median is 332. What does it mean? The mean is slightly greater than the median. The mean is slightly greater than the median. Okay. Median is 332. Mean is 355.2. Okay. Remember X bar is the mean. Okay. So that's what we did. Okay. Okay. We went through it. Okay. I talked about it. What is the mean? The mean is the point on the horizontal line. If it is a balance, if you put a fulcrum at the mean, it is balanced. It will neither the left will not go down, the right will not go up, or vice versa. That is the mean. Okay. It divides the frequency histogram into two parts. And what is the median? The median is a location where 50% below it, 50% above it. All these curves are frequency histogram. Remember frequency histogram? We plot relative frequency on the vertical axis, groups of data on the horizontal axis, draw a vertical rectangle on top of each group of number. Vertical rectangles, they touch each other. Heights of the rectangles are relative frequency. Widths are constant. And if you join the top roofs of these curves by a smooth curve, that's your frequency histogram. That's a curve like this, okay? So you have three different possibilities. The one on the left is balanced in the center. Mean is equal to median. It's a symmetric curve. Why it is symmetric on the left? Draw a vertical line. Sorry, draw a vertical line at the center of the red curve from the horizontal axis. The left half is equal to the right half. It's symmetric in nature. Look at the next one. The mean is slightly greater than the median, which is true in our control group. Mean is 355. Median, I remember, is 332. Mean is 355, slightly greater than the median. When does it happen? When there is extended tail on the right, as in the case of data set in the center. The mean is greater than the median because there are large numbers on the right tail which pull the mean towards them. The opposite might happen if there are too many small numbers. The mean will be pulled towards the small number. In this case, mean is less than the median, as in the third diagram in the bottom right corner, extended tail on the left. So one on the right, the red one, is symmetric. The one on the right middle, mean is greater than the median. It is right skewed or positively skewed, extended tail on the right. And one on the extreme right, the third curve, it is extended tail on the left. Mean is less than the median. It is called left skewed or negatively skewed. So point to note here, please make a note out of it. The relative position of the mean and median tells you about the skew. Skew means in which direction is the extended tail. One more time, if mean is approximately equal to the median, it's an approximately symmetric or bell-shaped. Symmetric means left half is equal to the right half in area as in the curve in the left. If the mean is greater than the median as the curve in the center, extended tail on the right, mean is greater than the median, large numbers pull the mean towards it. So what happens? This is right skewed or positively skewed. And when mean is less than the median, as in the third diagram on the extreme right, this is left skewed, mean is less than the median. Left skewed, sometimes also called negatively skewed. Okay, so this is baseball salaries. They made dot plots. Here you can see extended tail on the right. Although the number towards the left end has got the highest number of dots, that is, it appears the maximum number of times. The mean will be located close to that number with the highest number of occurrence. But there are other people who are making much larger salary. So this is an extended tail on the right. It's right skewed or positively skewed data. Okay. What do you do with categorical data, such as color of the car? Okay. So you can do a relative frequency. We discussed it, such as you go to the parking lot, 50 cars in the parking lot, out of which 20 are white cars. So what is the relative frequency of white category of color of car? 20 divided by 50 or 40%. Okay. So the sample proportion of success, in this case, success is to be having white cars in the parking lot, is 20 out of 50 or 40%. P with a thing at the top is called sample proportion of success. Why it is sample? Because your sample size in this case is 50 cars in your parking lot. There may be other parking lots which have different sample size and different proportion of white. So this is one value of sample proportion of success. Success in this case is white cars. Color of car is white. Why? Because I arbitrarily defined it as such. My proportion of success, my success is the color of the car is white. Okay. So I'm going to stop here today. I gave you an introduction of how to find the center of a data set. What is a center? Where majority of the number is. Why do I want to find out that? Because most of the time, that is the number in the center which occurs most of the time. Okay. And then there are numbers on the left of it, on the right of it. We also looked at median, which is the 50th percentile, 50% below it, 50% above it. And then we looked at the relative position of mean and median. If mean is greater than the median, extended tail on the right. If mean is less than the median, extended tail on the left. Negatively skewed, left skewed, mean is greater than the median, right skewed, extended tail on the right. And if the mean is equal to the median, symmetric. That means approximately symmetric. Left half is equal to the right half. Okay. So here you got some information of why we want to calculate the mean, because we want to find the center where most of the data point is located. The center of the data is also sometimes represented by the median, which is the 50th percentile. Percentile means 50% below it, 50% above it. That's what the percentile terms mean. So I'm going to stop here today. Okay, I'm going to stop here today. If you have any question, comments, please write me a note. Do not hesitate. Write me a note and let me know where you are watching from. Do you like this video? Please give me a thumbs up if you like my video. It really motivates me to produce more interesting videos just for you. And if you like this video, share with your friends. Give me a thumbs up. Give me a thumbs up if you like this video. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to watch me tomorrow when I'll be back with another interesting video. When you subscribe to my channel, please also hit on the bell button, which will notify you every time I upload a video. Thanks for taking the time to watch my video. I really appreciate it. I really appreciate the fact that you stuck with me till the end of this presentation. Thanks. Take care. Have a nice day.